Hey there, today we'll be going through this question that's longest subsequence with limited sum 2389, which appeared in weekly LeetCode weekly contest 308. And the question statement is you are given an integer array nums of length n and an integer array queries of length m. Return an array answer of length m, where answer of I is the maximum size of subsequence that you can take from nums such that the sum of its element is less than or equals to queries of y. So coming on to the explanation part, let's understand this question better. So what is it saying us? It's saying us that you will be giving us given a query and also a nums array. Okay, and you need to find the number of elements which sum up to such query which is less than or equals to that. What does this mean? So let's take the first query, that is 3. So how many elements are there which sum up to less than or equals to 3? So if we take 1 and 2, right, this will sum up to 3 only. And how many elements did we take? We took 2 elements right here, right? So the answer for query of 3 will be 2. Okay, and we need to maximize this. We need to maximize this. If we take 10, how many elements can we take such that their sum is less than or equals to 10? We can see that we can take 5, 4 and 1, right? So it will be 3, nothing but 3. Okay, so this is the question explanation. Now coming on to how we will do it. So let's understand this step by step. At first, what we can see or what we can observe here is we are needing the summation every time. So what can we do? We can actually sort the array. Okay, so the first intuition is sort the array 1 2 4 and 5. After that, what do we know? We need the summation every time, right? So how can we know the summation every time without summing up actually every time? So what we can use here is prefix sum. So we'll first take out the prefix array, and prefix array is nothing but the summation till index I. That means if I want to know what is the sum till index 1, it is 1. Summation till index 2, what is it? 3, because 1 plus 2 is 3. 1 plus 2 plus 4 is what? It is 7. And 1 plus 2 plus 4 plus 5 is what? It is nothing but 12. So how can we know that in O of one time? We can use a prefix array. So that is what we have done here. We have created a prefix array so as to get all the values in O of one time. Fine. Now how we are going to do all the operation for each query? Understand this. First here we can use lower bound. Why so? Because lower bound will give us all the values which are greater than or equals to the queries. And what do we mean by that? If and by the way, if you don't know lower bound, I'll be linking the link to the GFG article for lower bound if you don't know about it. Okay, but I'll still be explaining it right here. Let's just come here. So the query of I says, that is query of 1 says, at index 0 we have or we need all the guys who have summation less than or equals to 3. That means I need some elements who have summation less than or equals to 3. What can we do? We can do a lower bound here. And what will lower bound give us? The index, mind you. It will give us the index. Okay. So we see if we do a lower bound on this, what we are going to get. So these are the values or the indexes of each guy. And if we do a lower bound on this array, what are we going to get? We are going to get the index 1. Why so? Because it is present here. So for query 3 we see we got an answer of what? Of 1. We got an index 1 right here. Now what do we need to do for that? We see that we can take two elements here. Okay, so basically whatever index you get, that is the number of elements that you can take. And since this is a zero based index array, you just need to do a plus 1. Okay, so what is the index that you got? You got a 1 right here. So what will you do here? You will just put a 2. Okay, index plus 1, that is what you put here. So that is your answer for query 1. After that, what are you going to do? After that, you come here, you see for query 10, how many elements can you take such that the sum is less than or equals to 10? Now what will this lower bound give you? Right here you need to check and you'll understand the lower bound function. Lower bound will come here, binary search will happen, and it will see 10 is not there. So what will it return? It will return the next greater or the just next greater element for 10. Basically 10 is not present here. So what is the just next element which is greater than 10? is 11 present there, is 12 present there, or 13 present there, it will see 12 is present there. So it will return nothing but the index 3. Fine. So this is how I think you should have understood it. Okay, the lower bound. So now you see that you just needed 10, but you got a 12. What can we do? We do not need 12, we just need a 10. So if you just observe here, just previous index, the just previous index, that is the index 2, is having a value which is lesser than or equals to 10. That is the intuition. So if you receive a value, or if you get a value which is greater than 10, what do? You just do a index minus minus. Okay, so if you do a index minus minus, what will happen? You will get the value which is less than or equals to 7. And what was the procedure for writing the answer? Nothing but whatever index you got plus 1. So you will get 3 elements. Okay, now also here I would like to add a edge case to this part. What if, let's just say, what if you needed a sum which is less than or equals to 0? Okay, this case will never happen for 0. Why so? Because all the values are greater than 0, right? So let's just take some another example right here. This is a dummy array. Let's just say this is a dummy array. Okay, this is just for the explanation purpose of edge cases. Fine, let's just say you have 3, 5 and 9. Okay, and let's say you need a value 2. What will happen? See, these are the indexes 0, 1 and 2. What will happen now is it will try to find 2, but it says that 2 is not present here. So what will it return? It will return the value which is just greater than 2, right? It will return this index 0. So now we see that what were we doing previously? If we found a value which is just greater than 2, what we did was we did a index minus minus, right? So what is index minus minus? We will go out of bounds, right? It will be -1. So this is the edge case that you need to take care of, that if the index is less than 0, what do we need to do? We do not find a value which is less than or equals to that value. So what do we do right now? So we will just put a 0 here. Okay, so this is the edge case that you need to take care of for this case. And after that I'll be continuing further with the same explanation for whatever we were doing. So now coming on to this query, that is 21. So for 21 we see, we will get what? We see that 21 is not present here. What we will be getting is out of bounds iterator. So this is also one of the property. If the value is very big and it is not present there, we will get the value n only. Okay, so out of bounds iterator. So what we did was, again, if the iterator is not in the bound, what we are going to do? We are going to just do again a index minus minus. Okay, so all the cases in which the value is greater, okay, if the value is greater, we are doing a minus minus of index. Okay, in all the cases if the value is greater, or if we do not find it, okay, if we do not find it, if find, okay, not find, if we do not find it, in every case we are doing minus minus the index. So this part is important. And for every part, when we are doing minus minus index, we are just going to check for the edge cases. And what were the edge cases? That if index becomes less than 0, we just simply put a 0. Okay, so these are the edge cases that you need to take care of. So when we reached index n, that means out of bounds, what we did was index minus minus. And after that, what do? We see that this is in the bounds of array. So what we do right now is we just put index plus 1 as our answer, which is 2 3 4. Okay, and this is done. That's it. That is what you have to do in this question. So basically what you need to know is prefix sums and lower bound for this, and you need to take care of some edge cases. Okay, so that is what we need to do. Now coming on to the code part. Fine, coming on to the code part, let's see what we have done here. So basically this nums array, whatever was there, I did not want to change it. That is why I did it, I did a copy of that into temp. Okay, so basically this temp array is nothing but the nums array. Okay, this was not actually needed, but why I did it I still don't know. But whatever, let's just continue. What do we do next? We sort. As I said, while I was explaining, we just sort all the values. Okay. After that, what did we do? We found out the prefix sums, right? This was the prefix array that we found. So we can calculate the prefix array in the same temp only. Okay. We do not need to take extra space for calculating prefix array. We can do it in the same array. So I did it in the same array. Okay. This is the basic prefix finding. After that, what we were doing, we were finding all the answers for all the queries, right? Now coming on to this part, so we are iterating for all the queries. What this part is doing is, this part is nothing but the lower bound which we explained. Okay, this part is the lower bound, and mind you, I'll be linking the code in the description. Okay, so if you want the code, it will be there with the comments as well. Fine. So this is the part where we are getting the lower bound. After that, what we are saying is, I've divided into two cases, where I actually find it and where I actually don't find it. Okay, so what was happening is, at some point we were finding the elements in my array, at some point it was going out of index, like it happened here. Okay, so these are the two cases that I splitted them into. So what happens when I actually find it in my array? Okay, so this is the if condition for that. If I find it, if I find it, okay, in array of prefix. So this is the part where we find it. What do? We go inside it. Now what can happen? If we find it, let's just say that you wanted something like a 8. Okay, but you do not get it. What can happen? What will be returned? Just think. 12 will be returned, right? You might have guessed it. Since you do not find the 8, what does lower bound give you? It will give you 12. Now if we do not find it, what do? We just do a index minus minus, right? So that is what we will do here. We will simply just check if the value that I want is not present. Okay, if it is not present, the value that I want, or the sum that I want is not present. Okay, so what do? We just do a index minus minus here. Now we do a index minus minus, that is in this step right here. Okay, but what if we go out of bounds? I told you here also that whenever we were doing index minus minus, we need to take care of what edge cases, that the index should not be less than 0, right? That is what I told you while explaining. So this is the part where we need to check that if it is going out of bounds or not. So this is the out of bound case, right? So this is for out of bound. Fine. If it goes out of bound, what do? We just put a 0. But if it is inside the bound, this is the part where we see that it is inside the bound, we just do index plus 1. Why so? Because obviously it is 0 based. Okay, so this is the simpler part. But what if we actually found the value? Like in the case of 3, what happened was, we needed 3 and we found it, right? So what will happen? It will just go into this else condition, and it will just simply update it to index plus 1. Fine. And what is this else part doing? So this else part is saying the part when we actually do not find it. That means I was finding something, but it went outside n. That means I wanted, let's just say I wanted the sum 21, but do I find the sum 21? What will it return? It will return a iterator which is out of bounds, okay, which is n. Fine. So what did we do again when we went outside the bound? You guessed it, that is minus minus index. So when we went back, right? So we went back again. So again, if we go back, again we just have to do what? Whenever we are doing minus minus index, check for the edge cases. If the edge cases fulfill, you put the answer, otherwise you just put 0, right? So that is what we are doing here again. So if we are going out of bound, this is for out of bound. Okay, we decrease the index. If we go out of bound, we decrease the index. And this is the edge case check or the out of bounds check. Okay, bounds check. This is the bound check. That means, are we inside the bound or not? If we are inside the bound, we will just check that is the value actually takeable, or that means can we take it. If we cannot take in, we will again try to go further back. Okay, again go back. If we cannot take it, again go back. If we cannot take it, and when will this condition happen? Let's understand with this an example. Okay, let's just say that if you have something of an array, this is not a good example, but I'll just explain it right here. Okay, let's just say there is some array here. Fine, there is some array, just think of it. Okay, and you went there and you just are standing on some index, but you see that this index value is also greater and the previous one is also greater, so you'll try to go two step back, right? That is the at most you can go back, otherwise all the values will be lesser only, so you do not care about this. You'll try to go two step back, and if you still went two step back and you cannot find it, that means it has to be a zero. Okay, so that is what we are doing. We again try to go one back, and we do what? We just do a edge check at, okay, so this is nothing but the bound check that we are doing every time. So this part is very very important. You have to check for the bounds every time. If it is inside the bound, you put index plus 1, that is right here. If it is not, put answer I is equals to 0. But what if you actually found a value which is exactly equal? You do index plus 1. Okay, and you are doing I plus plus every time. And what is this I plus plus? This is just to maintain the index of the value. Okay, at which value or which index we are putting that value. Okay, so that is the whole code, and I hope you have understood the explanation. And if you want the code, it will be in the description as well. And if you didn't understand it, please do like and subscribe. And yeah, thank you for watching.